Welcome to Radio Fixer's channel. Subscribe for upcoming videos. I highly suggest going back and reviewing other parts of this beautiful ZENITH radio where we repaired the cabinet without staining the cabinet. We also tested all the resistor and replaced all paper capacitor in this chassis. Also, how to read and understand the proper connection for electrolytic capacitors on a schematic. Before we get started, I want to bring to your attention as YouTube a while ago changed the process of subscription. They made it more difficult for user. So here, as you see my screen, it shows subscribe. So yours, if it's like this and the bell is not on, you're not going to get notification. So use the drop down here and select all. From here on, YouTube will send you notification when I upload new videos. Also, meanwhile you're here, I try to make this as simple as possible. You can search playlist. There is a categories that you can go there and see. You know, it depends what you are interested. You're interested to fabricate part. Whatever it is, I categorize this to be easier for you to find a video. Hopefully this will help you. Believe it or not, this is the last capacitor in this radio that we need to focus on. It's a little different shape than the paper capacitor. I have two options. One, replace it with the same value of capacitor. Another, I put safety capacitor here. Since one side is hooked up to the power line, another side of this capacitor is soldered to the ground or chassis. Let's first look to see what's the value of this capacitor. So I'm going to key the information into the database that I designed and then double check that on the schematic and the location of the capacitor in the schematic. Let's focus on that. This side of capacitor is hooked up to this power line, this side. The other side, as you see, is connected to the ground. So when I zoom in, you can see the arrow goes that direction and is a green, definitely black and red. Let's key that into the database to see what's the value of this capacitor. We're also going to measure it with capacitor meter to double check the value of this. It shows 9.2 nanofarad. I'm going to show you this quickly. It looks like a mica capacitor, but it's not. It's a regular capacitor that they molded. So definitely you want to check this. This one has 4 colors. See, this is 3 and one here 4. Unfortunately, this was faded, so I couldn't read the voltage. So always you want to replace this. In the back, usually there's no color, as you see. Let's check the color code in the database to see what the database says. Yeah, this is the database I designed to make my job easier. Hopefully soon going to be available that I can offer it on eBay for those of you who are interested to purchase. Here, if we look at the 3-dot molded capacitor, of course, as you notice, the arrow goes this direction. So the color was green, black, red. So here the database is telling us this should be 5 nanofarad or 0.005 microfarad. As you saw, it was very off. So we have a choice to replace this capacitor with the same capacitor or safety capacitor. But let's look through the schematic to see what is the voltage on this capacitor. The schematic shows C26 is a 0.005 microfarad, which it match our database, and that is a 1000 volts capacitor. Of course, our last capacitor here hooked up to the power line. As you notice, is here, as you know in the schematic, if there is a dot, means it's soldered to. If there is a cross like this, it's not connected. So one side of this capacitor is hooked up to the power line, the other side to the ground. And that capacitor is C26. We have two options. One, use the same value of capacitor, which I do have some, or replace it with safety capacitor since it's hooked up to a power line. So let's talk about how we select safety capacitor. Line filter capacitors are hard-working capacitor and operate under very harsh condition. Depends where they located, like this picture is located before on and off switch. That means that it's going to be on all day long, 365 days. Line filter capacitor has to be able to withstand ongoing high voltages and voltage surges and spikes for years. And if it fails, it should not explode, catch on fire, or put people at risk of shock. For those reasons, it's a good idea to replace line filter capacitor with safety capacitors. There are two types of safety capacitors that can be used, for these old tube radios. One of them called cross the line capacitors. As you see in this picture, this capacitor is connected between the hot and neutral. For this type of capacitor, you can use X2 or Y2. The second one, as you see in this picture, they call line to ground safety capacitor. And that is what I have in this radio. As you see in this picture, one side is hooked up to the hot side of the line and the other side is hooked up to the ground. For this type of the capacitor, it should be replaced with Y2 safety capacitor. But please do not use X2 type for line to ground capacitor. The last one that also is available is a ceramic disc safety capacitor that is combination of X and Y classes. For example, an X1, Y2, this simply means that the capacitor meets safety qualification as both an X1 capacitor and also Y2 capacitors. Of course, these are more expensive than the other capacitor, and these are ceramic disc. Since mine is a line to ground connection, so I'm going to replace it with Y2 safety capacitor. Really, the best thing to do is when you're not playing your radio, unplug it from the wall. At least you know your radio, which you spend so much time to restore or fix, is going to be safe. Hopefully all this information is going to help you. As you notice, I installed that safety capacitor. I'm going to install also a fuse here, just because I'm going to give this to my daughter. I want to make sure that she's safe. Usually I don't install fuse, but for this one I'm going to install. Since I want to be safe, I install safety capacitor as well as the fuse. I know some of you might say this is too much to do, it's not necessary, but, just for safety. Because if it was my radio, I always unplug my radio after I play them. If the radio goes out of the house, I want to make sure to be safe. As you see, I installed this here. There was a bunch of holes already in the chassis, so I installed it right here. The hot side comes directly from the cord from the hot side all the way here to the fuse. Of course, goes through the fuse, then from here goes to the safety cap. That's the safety cap back there. And then, of course, from here goes to the switch, which is right here. So that's the hot side. All right. This radio, as you see, I set it up to the variac. It's about 120 volts. I set that for 120 volts. and it's giving me about 0.49 amp and operating in 117. There is a drop, of course, when you turn on the radio. So I think if I put 3/4 of amp, I should be fine for the fuse. I can go up to 1 amp. All right. In next episode, we're going to focus to remove this dial wheel and create a belt for it and put it back together. So stay tuned. At this time, I want to take the opportunity and thank my subscribers with their uplifting comments. You always encourage me to upload more videos, since this is just a hobby of mine. Again, I appreciate you. Enjoy all these videos, and you all have an awesome day. Take care. If you're interested to see more videos like this, feel free to subscribe to my channel, and you will be notified when a new video being uploaded. You have a great day.